So now let's talk about proving existential statements. So these are statements that look like for there exists an x and d such that q of x. So what you need to do to prove this statement, you need to find an x in the set D that makes q of x true. So what this is called, this method, it's called a constructive proof of existence. Because you're actually you're constructing this value of x and showing that that such an x exists. So let's look at an example here. We'll do 2. So the first one, prove there exists an even integer n that can be written in 2 ways as a sum of 2 prime numbers. So our mission, we need to find an even integer that can be written 2 ways as a sum of 2 prime numbers. So if you think about it, 2, you can write as 1 plus 2, but 1 is not prime. 4, you can write it as 2 plus 2, and that's the only way to write it as primes. Then there's 6. 6 is 3 plus 3, but that's the only way to write it as primes. 8 is 5 and 3. I think that's the only way to write it as primes. So then our next one, you're going to keep trying to find this value of n. And the first, I think, value of n is 10. So how can we write 10 as a sum of primes? We can write it as 5 plus 5. And you can also write it as 3 plus 7. And I'm going to say, and 3, 5, and 7 are all prime numbers. Now, there's not just one value of n here. There are probably other values you could have taken, but that's the one. You just need to find one of them. All right, let's look at another one. Suppose that R and S are integers. Prove there exists an integer k such that 22r plus 18s equals 2 times k. So you're trying to find this integer k. And so what have you done? You've really factored 2 out of your term here. So if I look over here and factor out 2, that will tell me what k needs to be. So k needs to be 11r plus 9s. Then we need to say why k is an integer here. K is an integer. Why? Because it is a sum of products of integers. Also, if we look at 2 times k, this is 2 times 11r plus 9s, or 22r plus 18s. So in both cases, we were asked to find the existence of an integer, and we found those. Now I do want to end this video by mentioning there are non-constructive proofs of existence. And what do they involve? Well, they involve, these aren't used a whole lot, but you can show an x exists that makes q of x true by axiom or theorem. So somehow there's some kind of previous result that tells us that an x has to exist, or maybe the assumption that there is not such x leads to a contradiction. So this is the idea of a proof by contradiction, which we'll talk more about later.